Hi, today we are going to see about the time response analysis in control systems. What is time response? If the output of control system for an input varies with respect to time, then it is called the time response of the control system. The time response consists of two parts. The first one is transient response and the second one is steady state response. The graph shows the transient and steady state responses. The responses corresponding to these states are known as transient and steady state responses. Mathematically, we can write the time response C of t as C of t equal to C suffix tr of t plus Css of t, where Ctr of t is the transient response and Css of t is the steady state response. The response of the control system during the transient state is known as transient response. In this, the input of the control system and the output set a time to reach steady state. Output in transient state till it goes to a steady state. The transient response will be 0 for large values of t. Ideally, this value of t is infinity. Practically, it is 5 times constant. Mathematically, we can write it as limit t tends to infinity, C transient of t equal to 0. Steady state response. The part of the time response that remains even after the transient response has 0 value for large values of t is known as steady state response. This means the transient response will be 0 even during the steady state. For example, let us find the transient and steady state terms of the time response of the control system C of t equal to 10 plus 5 e power minus t. Here the second term 5 e power minus t will be 0 as t denotes infinity. So this is the transient term. First term 10 remains even as t approaches infinity. So this is the steady state term. Activity. Standard test signals. The standard test signals are impulse, step, ramp and parabolic. To know the performance of the control system using time response of the output. Unit impulse signal. A unit impulse signal tau of t is defined as tau of t equal to 0 for t not equal to 0 and integral minus 0 to plus 0 tau of t dt equal to 1. It exists only at t equal to 0. The area of the signal under small interval of time around t is equal to 0 is 1. The value of unit impulse signal is 0 for all other values of t. Unit step signal. A unit step signal u of t is defined as r of t equal to a u of t, where u of t equal to 1 when t greater than or equal to 0 and it is 0 for t less than 0. It exists for all positive values of t including 0. Its value is 1 during this interval. The value of the unit step signal is 0 for all negative values of t. Unit ramp signal. Ramp signal is a signal which starts at a value of 0 and increases linearly with time. R of t equal to a t, where t greater than or equal to 0 and r of t equal to 0 when t less than 0. It exists for all positive values of t including 0. Its value increases linearly with respect to t during this interval. The value of unit ramp signal is 0 for all negative values of t. Unit parabolic signal. A unit parabolic signal p of t is defined as p of t equal to t square divided by t, where t greater than or equal to 0 and p of t equal to 0 where t less than 0. We can write unit parabolic signal p of t in terms of the unit step signal u of t as p of t equal to t square divided by 2 into u of t. The instantaneous value varies as square of the time from an initial value of 0 at time t equal to 0. R of t equal to a t square divided by 2, when t greater than or equal to 0 and r of t equal to 0 when t less than 0. It exists for all the positive values of t including 0. Its value increases nonlinearly with respect to t during this interval. The value of the unit parabolic signal is 0 for the negative values of t. Thank you.